Hi friends, welcome back to my channel. In this video, we will discuss about Java StreamAPI, which is a new feature added in this version. Now, if you look at the diagram of StreamAPI, see we have a source and destination. The source is something what we are passing, and the destination is what we are getting the output, which is expected as per the methods that are exist in this API. So same way, StreamAPI also have the source and destination, where we are passing the collection as input to the source, and by performing some operations in between using terminal and intermediate operations, as we have many methods available in between before the getting the output. Now first go, why do we need streams and how streams are working and the type of operations, and then next we move on hands-on experience. Right now, first see that Java we have a new concept called stream that is introduced in 1.8. It comes from the package java.till.stream. So this is one of the important topic in Java 1.8. Basically, what is a stream? It's a sequence of values over time. The term streams refers to the continuous transmission of data. In Java, a stream is a sequence of data. I have a question. Somebody asks the question, why we have streams if we already have a Java IO.stream package? The thing here is, it's the confusion, right? Streams that are introduced in Java 1.8 are not related to the file input-output concepts, and it's related to the collection of objects. Means to process the collection. Hence, if we need to perform some operations on collections, then we should go stream for StreamAPI. Now, you can ask why we have streams. Now, every Java application uses collection API, right, to store data, process data, or condense data, such. But using collection API, it is not always easy or not so easy to write some complex logics or code for some common data processing operations. For examples like filtering, sorting, matching, finding, mapping, etc. etc. Many methods are there. That's why we have the Stream API in Java 8 to implement more complex data processing logics with least number of lines of code. Right? How this can be done? Because streams support functional style operations on stream of elements. The Stream API is mainly used to process collection of objects. Means it is a sequence of objects that supports various methods which can be pipelined to produce the desired results. Means once we start processing the collection as input, as a source, then there are number of methods which can be pipelined. Using Stream API, we can modify according to the requirement, and the final output is our desired result. See, make a note, stream is not a data structure. Instead, it takes the input from the collections, and also streams does not change the original data structure. Stream does not store any elements also. They only provide the result as per the pipeline method. As I said, stream does not change the original data structure, which means that as we are passing the employee records as a list of employee records, where if you want to filter the employees by location, as employees are placing in different locations, right? So if you want to filter or if you want to get the employees based on their location, you just perform this operation, which means using filter. There is a filter method which is an intermediate operation. Using that, you can filter out the employees and produce a new stream without any changing the existing or source stream, right? You can, using stream, you can filter, collect, print, so on, so on. Then also you can convert from one data structure to another data structure, and one data structure to another data structure is much more. Assume the source stream is coming as a list. You can convert the, you can same way you can convert to list, or if you want to change the list to set, you can do. Or if you want to convert the list to stream, you can do. Or if you want to convert that list to map, set anything you can do. It's your wish. You can play with the methods available in the StreamAPI. Now let's discuss about the important operations. The first is intermediate operations. Intermediate operations are what? Simply we can say these are lazy operations. Operations which return another stream as a result are called intermediate operations. Means how it will happen once we process the stream before to convert to get the new stream. These intermediate operations are invoked on the original stream to get before we get our expected output. When we say lazy, stream is lazy, here means what? Most of the methods that are defined in java.util class is lazy. They will not work by just including them on the stream pipeline. When do they work? They only work when you call a terminal method. Means there is a terminal operations on the stream and finish. As soon as they find the data they are looking for, rather than scanning through the whole set of data. For example, few of the methods or intermediate operations are map, filter, distance, sorted, limit, skip, flat map. So we will discuss about all these things in detail when we start working on some hands-on examples. Next, we'll move on terminal operations. What do we mean by terminal operations? Terminal operations return a result of a certain type after processing all the stream elements, which means once we process the original stream, then with the help of intermediate operation, the terminal operation has to be executed. What is the terminal operation? At the end, means at the before the new stream has come out. So that is the output of this stream. In simple terms, terminal operations mark at the end of the stream and return our result as per the pipeline methods we have performed using intermediate operations. Once the terminal operation is invoked on a stream, the iteration of that stream and any of the chained streams will get started. Once the iteration is done, what's happened? The result of the terminal operation is returned. Here are the few terminal operations. What you can say for each: collect, min, max, count, any match, all match, done, find, any, find first. Like that, we have many methods are there. All these are terminal operations. So what will happen after processing the intermediate operations on the elements in the stream? We can collect the processed elements again into a collection. Alright? Again, where the destination, the terminal stream, means the output stream also a collection. That collection could be a list, map, set, string, or array. It is based on the requirement, we can do that. There is one more important method in this is collect. Collect is the method used to receive elements from a stream and store them in a collection, right? See, and go back to my Eclipse and show you that. See, here I have a list of employees which store the basic information and the sublist. Here employee ID, name, department, location, salary, etc. We have some static data that is already created, so it comes with the list of employees. So let's see here. As I am saying, the collect, it is a method used to receive elements from a stream. Means these are all the elements that is receiving from this source stream and it is collected in this method. And then what it do? It stores them into a collection. Here again it stores them using this. So this collect method which collects the final result. Final result means after performing the intermediate operations here using, like as told you, right, filter, etc. all this. So once we perform this, then the final result will be come and sit here. Means it collects the data which is processed. So it is extremely useful terminal operation, right, to transform the elements of the stream into different kinds of results. Different kinds of results in the sense, see, to list, to map, as you see here, as we have many number of methods are available. See, to collection, to concurrent mass map, to list, to map, to set, as many methods are available. So according to the requirement, we can convert to that data structure. Then we can, once we collect the process elements again to collection using this stream methods only. So this, the collectors class here, as I said, this collectors is the class is very similar to utility collection class. It is full of static methods only. If you see this, what is this method here? You said it's a static method. That is why we are saying it's content full of static methods, which helps us to convert, to change to different data structure, which you can use along with the collection. We can wrap, filter elements into set list by using these character classes, right, as the methods that are available for us as per the requirement. Now, as I told you, right, find first methods in Java 1.8, right, this in non-parallel stream both are used. First, how it helps us find first and find any methods means it retrieves the first element of the string in most cases, but find any does not offer any guarantee over this behavior. So I recommend you, please use find any to get any element from any parallel stream in faster time. Else we can always go with find first in most of the cases. It's one of the most feature and flexible operation. It's very commonly used to calculate. So, and then now go back to this reduce. So this reduce is one of the most and frequently used method to calculate aggregate results of collection. What is this? This stream.reduce method is a reduction operation. A reduction operation is what? It takes the sequence of input elements and combines them into a single summary result, right? We can perform a reduction operation on elements of Java streams using stream.reduce method. So you can see the basic syntax and how it works. Here I have a list of integers. You see here 2, 4, 6, 8. Now see this collection as stream that using reduce method I am performing some operations. What operation we are doing here? The first operation is sum, which means I am trying to get the sum of input elements which are in the list. So if we print this, what we get? We will get the sum of this. Here I use the method reference from the integer class. See, when you print this, the expected output should be 6, 4, 10, 10, 18, 20. See this. So in simple way, we can perform aggregate operations on this using this reduce. In another way, you can see I can get the maximum element from this stream. What is the maximum element in this list? 8. So once you run this, you will get the max element is 8. Now in the same way, if you want to get the minimum element, which in this case the minimum element, it will look at this default value also. Since we are providing the default value as a as a part of syntax, if we want to consider this value also, it will look at this as a default value and return to us as a minimum element, say 0. If you don't want to consider the default value, if you don't want to give the default value, you can remove that and run. It will consider the minimum element from the input stream. See, it is 2 is the minimum element. This is how this reduce operation will help us to perform our aggregate calculations. Then next move on to the next thing is map and flat map, which are the main and most useful and frequently used methods in the StreamAPI. These are very useful for us when we are working with the stream. Let's see how this will help us and where we are using. Just go back. First, stream. See, as stated, all these are part of stream only. Stream interface. Since both map and flat map methods, both are intermediate operations only. See how this map helps us. It is used to transform the collection. Means transform the collection means the original stream, the source stream, we can change according to the requirement. And how? What is the requirement? It could be depend on the use case. See, for example, in my case, here we have the list of employees here. As we see here, I have a list of employees. This list of employees having the basic information, ID, name, so on, so on, so on. So here what we are doing as saying transformation means I don't want the list all the attributes from this employee. I want to perform something, some logic as per my requirement. For example, now I have employees. Now where I want to get the name of the employees, I don't want the complete set of data. This case what we do, okay, here there is a scenario where I don't want the employees all the attributes. No, I want to print only employee name, or sometimes it is a requirement to print employee name followed by location or followed by department or employee ID and his name. So in that case what we do, we take the original stream and transform according to our requirement, and then again we convert back to another stream on another data structure. That is how you can type converting that list of employees to string or to list to set, whatever may be. So this is where the map is used, meant to transform your collection. Simply you can say it is also a one-to-one mapping, which means it is always process, means it will always transform only one stream. Okay, coming to this flat map. Before we go to flat map, I just want to say one point here. In map operation, a function is applied to each element of the source stream and return values are inserted into a new stream, as said, right, which is written earlier. The thing is, the key point to note here is that the function used by the map operation return on a single value, right? That's, now next move on to the flat map. What do you mean by flat map? It is simply we can say one-to-many. This one-to-many mapping is created where for each input element or stream, first what we do, first we'll get the multiple values, and that will have another stream. So to get that inner stream or substream, we use flat map. How this helps us? It helps us to flatten a stream of stream. Means it processes stream of stream elements into just single stream. See, in my case, here we have employees, right? Employees are working under different projects. To get this inner stream, inner collection, we use flat map. Using flat map, we can easily bring all this data. So the basic syntax, now I will show you now how it works. Just go back here and say now employees dot. First what we do, as all collections we have to stream that. Once we stream that, then we go for our actual thing. Stream dot. What we do here, we are discussing about the flat map, how the looks flat map. Let's first see how the map looks now. Then we go for the flat map. See this flat map here. What I'm trying to employ from the list, from the employee record. Employee is record is this format: ID, name, department, location, salary, etc., etc. But my case, I don't want all this. I just want to transform my object to something different. Say get emp id. I just want to print emp id and followed by name. So how do I do that? Emp dot get emp name. So I am done with this. Means I am done with the map. What is the next operation? Once we perform the intermediate operation, there is a collect method as discussed. This collect method collect the final results, and then we have to convert to some new data structure, right, with the help of collectors class. Sorry, see, this is a collectors class. This also come from java.util.stream. Then to which I am going to convert to string. To do this, I am joining using some delimiter. So as now we use comma. Then just copy this and print how this should. pass this to sysout and then print. Run as. See how it takes place. Employee ID followed by name, employee ID followed by the. See, this is how the map works, means transforming your collection. Now coming to this flat map, as I said, again we take this employees collection and stream. Now what we are trying, as per the definition, we say it process stream of stream. What is the first stream? Here it's a flat map. So what the flat map do? First it has to take the outer stream. What is the outer stream here? Employee dot projects. So first we are getting employee projects. CMP dot get project list. This is again one of this inner stream. So this is again a list. So again we have to stream this. See dot again I am streaming. Next what we do? This stream we have to connect to different. How to do that? Using collect method as discussed. This collect method again convert into data structure as what they call. What to say? Again I will convert to string. Here I just this time say join. Sorry, 2 is not there. Joining. Again all these projects I want to print using comma separated. Now pass this to sysout. Then see the output how it prints. It prints the list of projects that on each employee is working. See, as it is showing project 1, 2, 3, 4, 5, 6. As the some project names are repeatedly coming. So for that, what we do, we have a method distinct. Right? Using distinct, we can simply ignore the duplicates. Where we use that one? Here stream. When we perform stream, right? Our stream is ready. Then say distinct. Right? Now after performing this operation, again I will show you what happens here. Now we are getting distinct project, but this is not in the sorted order. To do that, again once I perform distinct, what I do, I will say sorted. This is a natural sort order, means default sort order. Then run this and see. This is how it's 1, 2, 3, 4, 5, 6. See, this is how the map and flat map works, the basic thing. So in the upcoming tutorial we will discuss more about on the StreamAPI methods. As of now, thank you. We'll see you in the next video. If you like my videos, please subscribe so that